All right, this experiment is a very fun one, and it's almost like a magic trick. So it involves the topic of conduction. Conduction is when heat is transferred by direct contact. So what you're going to need to do this experiment is, first, it is absolutely necessary to have parent supervision if you are going to do this. If you do not have a parent in the house, do not do this, because we are using a candle. And I do not give you permission to use a candle by yourself. You must have a parent present to supervise this. And whoever that parent is probably going to be blown away by this science, okay? So first, I've got a balloon. It is not 100% necessary to have a balloon. This one is just filled with air. And what do you think is going to happen when I put the balloon filled with air over the candle? Go ahead and make your prediction now. Let's see. Okay, there's no surprise there. And of course it blew out my candle, so I'm going to have to relight it. Okay, now the difference is, with a balloon filled with water, will that do the same thing? If I hold it over the flame, will it pop? Make your prediction now. And let's find out. I'm not positioning the camera in any weird way. Be very, very careful if you're holding this. I'm kind of dangerously close to the convection current. Now, my question for you is, why is this balloon not popping? This is from the same bag of balloons as the blue one, so the color has nothing to do with it. Be very, very careful if you attempt this yourself with parent supervision, because you will notice that directly over the flame, the convection current is very, very hot, so you wouldn't want to get much closer than this. But I'm curious to know, how long do you think I could hold this? I can put it right in that flame, and you can see for yourself. It is not popping the balloon. So kind of a neat trick there, but the science behind it involves conduction. So we'll talk about that more in just a second. So I am curious to know, would the same thing happen? I know a plastic cup in fire would melt, but would the plastic cup, would it burn a hole through the cup if I put this over there? I've never tried this. This might actually burn a hole, I'm not sure. Whoa, I feel it moving, but if you can see there, I don't want to pour the water out. It is dark on the bottom, but it did not burn a hole. Will it burn a hole through a water bottle? Still no. Why is that? Why is it not burning a hole through it? How about a plastic bag filled with water? Wow. So what a neat science trick. What if I remove the water? Now, of course, I don't give you permission to do this, because this could produce toxic fumes. But that doesn't look half bad, but I know for a fact that if I were to hold this over the flame, it could potentially catch on fire here, so I'm not going to do that. But you saw it shrivel up and start to melt right there. Same thing with the cup. I'm not going to catch it on fire. But without the water in it, hole burned right through it instantly. So I know that that would happen with the other things. So my question to you is, why does a water balloon filled with water, obviously, not burn a hole in the plastic? Thank you for watching. Write your comments to this assignment and have a great day. If you want to try this, remember, absolutely must have parent supervision. Be very, very careful. Do not burn plastic. Do not inhale flames. Do not play with lighters. Do not play with matches. You know what I mean. So, cool trick. Thanks for watching. Answer the question. Why did it not break?